Hey there, welcome to the whitchermath channel. Welcome back. Coming in hot right now. A wicked mental math strategy. A cool party trick. It's just a way to answer questions like this that come up all the time. Hey, Joe, what's 32 squared? Joe says 1024. His friends freak out. They think, how does he know that? He is a math genius. Well, maybe he is, but chances are he might know this little trick. I'm going to use a very simple example. Okay, very simple. Okay, let's say everybody knows what 5 squared is, right? But let's say someone asked you, hey, what's 8 squared? Or better yet, what's 6 squared? Pretend you don't know what that is. Well, you would just take, if you're one away from a known square, here's what you do. Here is what you do. Take the known square, add the root, add the next number, there's the new square. There's our known square, there's the root, and then there's the root plus 1. Okay? Hey, let's do that again. Let's say someone asked you, hey, what is 11 squared? You could either say, I don't know, or you could remember this little trick. Check this out. You already know what 10 squared is, right? That's 100. Then when you add the root, and then you add the next root, you get it. So you go through this process. This just takes a split second in your mind, and then you're able to answer that. Wouldn't you rather say that instead of that? I think so. What happens if it's 2 away? Well, as I always encourage students, if it's a math thing and you're wondering what if, well, go ahead and do it and find out. Let's take our same simple example and say someone's asking you, what is 7 squared? Well, let's take our little system here. We take the known square, we add 5, add 6, add 7, and that's 43. Wah, wah. And that's wrong. And you think, Mr. Witcher, I'm going to unsubscribe and I'm never going to watch your channel again and I'm going to report you to the authorities. Well, let me explain what you need to do in this case. All right? When you're 2 away, you're going to take the known square plus its root plus the root plus 1 twice, and then the next one, the one that you want. And guess what you end up with there? Right. Okay? Because that gets me to 6 squared, and then that gets me to 7 squared. Okay? So if you move for each one away from the known square, you need to do this situation here. Okay? So at that point, there's the end of the trick. It's a little mental math trick. Now, if you want to go further into this, why does that work? How does it work? It's brilliant, but you actually want to understand it? Well, if that's you, we need to party, cowboy, because if that's you, you're speaking my language. I love to explain why something works, and I love students to understand why something works. So here's how this came up in class. We were looking at a little table of squares. Actually, we were graphing a parabola, but what we had here was roots and squares. 1 squared is 1, 2 squared is right, for this equation. 2 squared is 4, 3 squared is 9, 4 squared is 16, etc., right? We'll do one more. And I was asking students to think of, well, what pattern do you see here? This is not linear. It doesn't make a straight line if we graph it. But what is the pattern? What's happening here? And one thing students noticed was that went up by 3, that went up by 5, that went up by 7. It's increasing by consecutive odd numbers. And that's a cool thing to observe. Can we take that a step further? Well, 3. If I add 1 and 2, there's my 3. If I add 2 and 3, I get 5. And we all kind of recognized, hey, wait, there's more to it than just, like, where does that odd number come from? It comes from the current root plus the next one. When I add them together, I actually get the next square. So I get this kind of pattern going on. Take this, find the root, add the next root, you got the next square. And it's this cool little number sense thing. And then I started thinking, well, what if someone asked me a really hard square, and me as a teacher, I need to pretend like I know everything. How could I do this? And I figured it out, and I shared it with students. Okay? And here's how it works. Here's a 3 square, right? It's 3 times 3. Now, if I go to a 4 square, which we already know is 16, but we like to use simple examples to learn algorithms and then apply them to big complicated problems. What happens here is, when in the process of going to a 4 square, I have to add 3 and I add 4. Okay? That's where that 7 comes from. Okay? So now, what happens if I go from a 3 square, because remember that trick was going to the next one. What if I need to go 2 away? So I'm going to go from a 3 square to a 4 square, and let's go to a 5 square and see what happens. Okay, so I've got the 3 square, and I'm adding 3 and 4, but then to get to the 5 square, I'm adding 4 and 5. So earlier in the video, we had that number being added twice, and now you can physically see where it's coming from. So 5 squared equals 3 squared plus 3 plus 4 plus 4 plus 5. And then, of course, that equals 25. Okay, which we already knew. My point is, if you're trying to figure out something very complex, like let's say 32 squared, how's that going to work? Well, we're not going to draw a big square all over paper and then the party's over and nobody's there to hear your cool answer. But we can do this. We know that 3 squared equals 9. So 30 squared equals 900, right? Because we have the 0 getting distributed twice, right? 30 times 30. There's a 0. There's a 0. Okay, so we know 30 squared is 900. And so I can go plus 30, plus 31. And then if you have this picture in your head, you're going to know, oh yeah, I need to add 31 again. And 32. Okay? So it's not that hard to mentally put those together and say, oh, that is 124. And then you have 1,024. 32 squared. Okay? It works for subtraction too. It works for subtraction. Wait, don't go yet. Nobody's left watching now anyway, so I'm going to go ahead and talk about this. This works for subtraction. Here's what I mean. Let's say someone says, what is 8 squared? Pretend you don't know, but you do know that 10 squared is 100. Well, you would go, using the same system, you would go 100 minus 10 minus 9 minus 9 again minus 8. What does that make? 100, see, that makes 90, 81, 72, 64, right? And you already knew that answer, but I'm just demonstrating that this does work for subtraction. Like, for example, 19 squared, well, who's going to do this? That's too rough, okay? But you could do this. My nearest square that I know mentally is 20, right? So I could do 20 squared minus the root minus the next root, and I get 361. That's pretty cool. That is pretty cool. If you're dorking out like I am, that is very cool. You don't need to memorize squares to know squares. So, thanks for watching. All the good stuff was the first 4 minutes of the video, and then all the really good stuff was the rest, and I appreciate you hanging tough, watching the whole thing so you can understand this and not only do it, but explain it to other people. You are powerful, and thank you for watching the Whitcher Math channel. See you later.